Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 389. Find the difference. You are given two strings s and t. String t is generated by random shuffling string s and then add one more letter at a random position. So t is generated by the shuffling of each characters in the string s and also we are adding one more character at any random position in t. Return the letter that was added to t. Fine. So see here, A, B, C, D, A, B, C, D, and E is added one more. We want to return this E, right? So this is what a question. And let us see here. S is equal to empty string and T is equal to Y. Now I want to return this Y, right? Fine. Now how to approach this problem? First of all, here we can take the each count of each elements in S and each count of elements in T. Let's take example. S is equal to A, B, C, D, E and T is equal to A, B, C, D, E. Oh, here I wrote E, right? Just erase it. Fine. Now this is my strings. Now how can I approach this problem? Now I want to take the count of A here. My count of A is what? 1 in this S string. B is 1, C is 1 and D is 1. Fine. Now I want to take all the count of this T string characters, right? A is 1, B is 1, C is 1, D is 1 and E is 1, right? Now compare. A is 1 here, A is 1 here, B is 1 here, B is 1 here, C is 1 here, C is 1 here, D is 1 here, D is 1 here. But E does not found in S, right? So I can find the element which is extra, right? Now how can I implement this approach? I can use either a hash map or a frequency array, right? So hash map is just like a hash map, but still the frequency array is like we have 26 initially zeros, where this first zero denote A count and the second zero denote B count and C count and D count, etc. so on up to Z count, right? So let me explain this approach. Just see here. I just initially take a array of size 26 and initialize with 0 etc. so on up to Z. So this denotes what? It denotes A, this denotes B, C, D, E, F, etc. so on up to Z, right? And then index are 0, 1, 2, 3, 4, 5, etc. so on up to 25, right? This is what I index. These are my imagination. Let us assume. Okay. Now, what is my S string? A, B, C, D. Right. Now take this A and subtract with A. So A minus A, which gives 0, right? So increase my count. Now take this B minus A will be 1. Because B's ASCII value is 98 and A's ASCII value is 97, which is equal to 1. So increase the count. Now take C, increase the count. Take D, increase the count. Fine. My array looks like this, right? Now take the string T. In string T, it is A. Whether I want to add this A or I want to minus this A. First of all, we get A minus A, which is equal to 0. At 0th index, whether I want to minus 1 or plus 1. I want to minus 1, right? Because we are going to check whether the extra element is there or not. Okay, so we first assign all the characters in S to that array. Then we want to assign all the characters in the T to the array, and the element which is not equal to 0 is our target, right? So take this A minus 1, it will become 0, right? Again take this B minus 1, 0. Take this C, minus 1, 0. Take this D and minus 1. So 1 minus 1 will be 0, right? Right? Now again, it is D, sorry, it is E. Now E minus A is equal to 4. I want to minus at 4th index. Minus 1, right? Now my array looks like 0, 0, 0, 0, minus 1, and remaining all are zeros, right? Now I'm going to check my array. First I am at this position. Whether it is not equal to 0, no. Next, whether it is not equal to 0, no. Whether it is not equal to 0, no. Whether it is not equal to 0, no. Whether it is not equal to 0, yes. So what is its index? Index is 4. So 4 plus 97 is equal to 101, right? So it is the ASCII value of E. So return E. So this is the first approach. This is our first approach, has table approach, right? This is the first approach, has table approach. Okay, fine. Talking about time complexity. What is the time complexity and space complexity? Time complexity is O of, we are going to traverse this S. S may be like M, N, and T. T is what? It is N plus 1, right? So plus N plus 1, right? This is for traversing the T. Plus we are going to check each and every element in this array. Initially this array size is 26, so plus 26, right? So overall the time complexity is O of N. Why I am using this plus? We are not putting the inner for loop. We are just traversing first to this S, then to this T, right? And the space complexity will be O of N. Sorry, O of 26, which is approximately equal to constant space, because we are using a 26 sized array, right? So this is my observation for this first approach. Now whether we can optimize it, let us see. S equal to A, B, C, D, T is equal to A, B, C, D, E, right? Now let us take in different view. Let us take, it is a array 1, 2, 3, 4, and this is the array 1, 2, 3, 4, 5. If I ask what is the element that is occurring extra in this array, then what will be your answer? It is 5, right? It is 5. But how can we enter this? How can we think about this logic? Just see. I can add this all elements. Then what is my answer? It will be 10, right? Then add this all element. It will be 15. If I minus 15 to 10, it becomes 5, right? I can find this element. So can we use this logic here? Let us see. First of all, we can take this T and sum up all the elements. So what is the elements? I can take the ASCII values. First is 97 for A, 98 for B, then 99, then 100, then 101. Fine. Now I am going to add this all thing. Let it be x. Now take this yes, and add all the things. So take this yes, it is 97, 98, 99, and 100 for D, right? Let us take this equation number 2. This equation number 1. Let us take equation number 1. Now what I have done in previous thing, I have subtracted this T by S, right? So do the same stuff. 1 minus 2. What is my answer? This 97 cancel, 98 cancel, 99 cancel, 100 cancel, and remaining 101 will be an answer. 101 will be an answer. So this is what? E. Right? This is my second approach. So what is the time complexity here? Talking about time complexity, the time complexity is we are traversing only one time in S and only one time in T. So it is O of N plus 1. Let N be the length of S, right? And what is the space? It is constant. And time complexity can be written as approximately O of N. We optimized it, right? And this method is for math approach, right? Okay. Can we do in any other approaches? Yes, we can do it in bit manipulation approach, right? We have already studied what is bit manipulation approach. Let us see what it is. Just like this, right? Now take the same data. It is 97, 98, 99 and 100, right? Here 97, 98, 99, 100, 101. If I do XOR operator, this 97 I do XOR operator, this 97 and this 97 cancel, and this 98 and this 98 cancel, 99 and 99 cancel, and 100 and 100 cancel, and cancel means it's all 0, right? Now 0 XOR 101 will be my answer. So which is equal to 101, which is I am returning the character E. Right? This is my bit manipulation approach, right? This is my bit manipulation approach. This third approach. What is time complexity and space complexity? Talking about time complexity, it is O of n plus 1, which is approximately equal to O of n, right? And what is the space complexity? It is constant space. It's a constant space. So this is the optimal approach. We can also solve this question by using hash map. So I will be showing that in code, right? It is equivalent to the frequency table, right? Let me show you the code. First I can show you the Python code. In Python and C++ it varies different. So let me explain in Python first. See here is a frequency table. So I have declared the 26 size list, then frequency of order of I minus 97. This order will convert the character to its ASCII value. If order of A, it means 97, right? So I am minusing every character with 97 and incrementing one value at that index, right? Then I am going through I in T, then I am going to minus in every index. Now for I in range of 26, if the frequency of I is not equal to 0, if that element is not equal to 0, if that index is not equal to 0, then I can say does the answer. So I will do plus 97, then I change into character. That's why I am using CHR, right? Then I am returning the answer, right? So this is my first approach. Let me submit it. Then this is my second approach. See here, it is submitted successfully. Then this is my second approach. Answer is equal to 0 for I in T. Answer plus is equal to order of I. So I am adding the ASCII value of every element in T. Then I am going to subtract the ASCII value of every element in S, so that the remaining answer will be my results ASCII value, right? So I am converting it into the character and returning it. Fine. So let me submit it. This is a math approach. See here, it is submitted successfully. Then at last, it is a XOR approach. See here, answer is equal to 0 for I in T. Answer XOR is equal to order of I. For I in S, answer XOR is equal to order of I. So return the character of answer. So why I am using here order? Because in Python we cannot do a direct XOR for character and character. So we want to convert a character into an integer, then we want to achieve it, right? So let me submit it, then I show you the error. So it is submitted successfully, right? If I'm writing like this, it shows an error because no integer and character can be XORed in Python, right? Okay. Can we XOR a character and a character? No, that's also not possible. Let us assume answer is equal to A, and doing A is a character and I is also character. Like it is string, it is also string. No string data type and string data type can be XORed. So that is the error. Unsupported operand type. It is also str and it is also str. That is, it's also string. That's also string. Okay, fine. So this is the error occurs in Python. But if you are doing in C++, there's no error or no restriction in it. Let us see. I have done a submission in C++. Wait a second. Here it is. Yes. Let me explain this. This is the map approach, right? This is the hash map approach. See here. I will iterate through every element in T, then increment it by 1. Then I will iterate to every element in S. Then I will make it at. Then I decrement it by 1. In this scenario, when the value is equal to 1, I will return the character, right? So this is the hash map approach. then this is a dummy return. This is a dummy return. We don't want to return it. Okay, it's don't get executed, but still in C++ we want to return a dummy return, right? Wait, I will show you. Yes. See here. This is a math approach. Sum is equal to 0. I directly adding t of I, because in C++ it will what? It will convert the characters into a integer type, right? So if it is t of I is a, it automatically convert a to its ASCII value 97, right? So that is the beauty of C++. So it automatically converts and store in sum. Then it automatically converts and store in sum, so that I can return the sum value, right? Then now at last this is a XOR. XOR also we can do directly this 0 and this character. We don't want to convert this character into its ASCII value, right? So let me submit it. Wait, I can comment it all and submit it and show you how C++ works. See here, I can submit it. Yes, it is submitted. So in C++ you can use like XOR with integer and character, but in Python you have to use XOR only with integer and integer. Make sure. Okay, fine. Thank you.